Hello and welcome. This is going to be our homework help video for the practice test for patterns, equations, tables, and graphs. Let's jump right into it with problem number 1. Here are 3 figures in a pattern. Sketch the 4th figure. So whenever we have to sketch another figure in a pattern, what we always start by doing is identifying if this is an adding pattern. Is it getting bigger? It is. And if it is, we just sketch the previous pattern. I'm not holding this right. Okay. Sketch the previous pattern just to start. So it looks something kind of like this. And then we ask ourselves, well, how is it growing? Well, I just have to keep comparing them until I can see the pattern. From here to here, well, this one's new and this one's new. So it looks like it added on to the end. And then from here to here, this one's new and this one's new. So it looks like we're adding to that first and third row. So that's where I'm going to add the new boxes. Just like that, that's what figure 4 is going to look like. Make a table representing the pattern from number 1. So for this, it's just a big blank, so you can make this table however you want, but I suggest numbering our X column 0, 1, 2, 3, 4, 5. And I always like to include 0 because it helps me do things like graph, which is what I need to do in part 3 here. And now to fill in our Y column, I go and I just count 1, 2, 3, 4. So figure 1 has 4, so across from the 1, I want to put a 4. Figure 2 has 1, 2, 3, 4, 5, 6. Figure 3 has 1, 2, 3, 4, 5, 6, 7, 8. The next one has 10. Now let's check in and see if we can find a pattern. To get from 4 to 6, I needed to add 2 and see if that pattern continues. From 6 to 8, I also add 2. From 8 to 10, I also add 2. So it's probably pretty safe to assume that to get to the next one, I'm just going to add another 2. 12, which is also consistent with what we saw up here. We were adding 2 blocks each time. Now what if there was a figure 0? How many blocks would it have if I went backwards with this pattern? Well, if I add 2 to move down, I could subtract 2 to move up. This becomes a 2 right here. All right, let's take that table and graph it in part 3. Make a graph to represent the information from 1 and 2. I'm only dealing with positive numbers, so I can just draw the first quadrant of my graph and just kind of plot these points. So 0, 2 is going to be right about there. I'm going to decide that that is 2 right there. 1, 4. I'm going to decide that it's right about there. 2, 6. Just kind of trying to keep these relatively even. 3, 8. And we could keep going, but I'm running out of room, so I'm just going to call that good. Goes up like this. Maybe we should actually use a dotted line since there's no in-between numbers here. All right. So however you do that graph is fine. Try to make it look like the y-intercept is at 2, because we know that that is where it is. For each one, determine whether the table is linear or nonlinear and state why. Well, for this one here, we can see our x's are counting by a very even interval. They're just adding 1 each time. So if this side is constant and this side is constant, which it looks like it is, then we know that this is linear because it has a constant rate of change. It is changing by the same amount each time. Let's look at this one over here. There's something very interesting about this table. We have 2 values for -1. So that automatically makes this nonlinear. Those 2 values are going to be right on top of each other, -1, 5, and -1, -5. So the only straight line would go vertically through them. But I also have this point here at 0, 0, and 2, -6. There's no way to connect all of these with a straight line. It would have to be either curved or have lots of bends in it. This is just not linear, so it doesn't make a straight line. Does not make a straight line. All right, let's take a look at the next page. This is a way of organizing all four of our representations of a function. You can see the one filled in is the equation. We don't have to do anything else with this. We just need to take this equation and turn it into a pattern, a graph, and a table. I'm going to go to table first. I've always liked tables. When I make my table, I'm going to include some negative values to help me with my graphing. I'm going to start at -2. I go to -1, 0, 1, 2, 3. You can do a different interval if you want, but I really like this interval here to give me a really good idea of what's going on. Now, in this equation, I can see that my starting value, my b, is 2. So b equals 2. So that means across from the 0 should be a 2. Also in the equation, I can see that my m is equal to 3. So that's what I'm going to count up by. So to get to my next number, I need to add 3, which gets me to 5. Add 3 gets me to 8. Add 3 gets me to 11. You can also double check that one of these points works by maybe substituting in 3, seeing that I get an 11 out. Y equals 3 times 3 plus 2. Y equals 9 plus 2. Y equals 11. So it works out. Let's go backwards by subtracting 3. Now I'm at -1. Now I'm at -4. Again, you can double check by plugging in one of these numbers, make sure it works. Let's draw a pattern now. So with patterns, it's important to always start with either figure 0. If you start with 1, then just make sure that it's got the right number of boxes. It's easier to start with figure 0. Figure 0 should have 2 boxes. So 2 boxes. Figure 1, I'm going to copy those 2 boxes. And how many boxes am I going to add? Go look at my slope again. It's a 3. I'm going to add 3 boxes. Let's count them up. 1, 2, 3, 4, 5. Is that how many boxes figure 1 should have? Figure 1, 5. Yes. All right, let's just keep that going. I'm going to copy that down here, and then I'm going to add 3 more boxes. Do it again, copy down that figure, and then add 3 more boxes. And let's check this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Should figure 3 have 11? It should. Last thing to do is to make a graph. I'm going to draw all 4 quadrants because with an equation, I think it's okay to go into the negatives. And just plot the ordered pairs. 0, 2. 1, 1, 2, 3, 4, 5. 2, 8. So I go over 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. Go the other direction by counting down by 3s. So you notice between these points, I can always get to the next point by going 1 left and 3 down. So let's just keep that going. 1 left, 3 down. 1 left, 3 down. 1 left, 3 down. We see it makes a straight line. Probably would want to connect this up with well, we could actually go with a solid line because we started with an equation, which does allow for those fractional values. All right. Given the following graph, fill in the table. So I'm going to look here, what x values are covered. I can pick anything from -3 to 2 because those are all covered. I'm just going to start at -2, then go to -1, 0, 1. Now to get the corresponding y value, I've got to go to -2 on my x-axis and then count down to my line. 1, 2, 3. I counted down, so that's a -3. -1, -1 is also on this graph. 0, 1 is that point right there. 1, 2 is also on my graph. You could also just dot in, 4 points on this line and then put them into the table. But I like that I've done this here so that I get a nice constant rate of change. Easy to see in my table. Given the following equation, fill in the table. All right, so let's pick some more x values. I'll go -1, 0, 1, 2. Just picking some integers close to 0. Across from the 0 should be the 5. I'm counting up by 4s. So 9, 13, or counting down by 4s to go the other direction so that it keeps that +4 pattern consistent. And we can check with a point. Let's check with 2, 13. Y equals 4 times 2 plus 5. Y equals 8 plus 5. Y equals 13. Checks out. All right. Given the following table, create a graph. So just got to treat these like ordered pairs and plot them. That first row gives us the ordered pairs -2, -8. So -2, -8. 0, -4. 1, -2. So notice we skip some values, but as long as we're being consistent with how we graph these, notice it's still making a straight line, which is a good sign. And 5, 6. All right. Consider the following pattern. We got some ice skating penguins here. Is this pattern linear or nonlinear? Well, let's just see if we're adding the same amount. To get from this one to this one, we added 2. To get from this one to this one, we added, well, we went from 4 to 1, 2, 3, 4, 5, 6, 7. We added 3, so that's nonlinear. Give one mathematical reason to justify your choice. It's not a constant rate of change. State the rate of change in starting value for this equation. Rate of change is 3, starting value -2. And we've reached the end of this review. Hopefully that's been helpful. And have a good rest of your day.